Alright, so for this example, we are given a polynomial equation of f of x, and we are told to Taylor expand it in the first part. Given the equation, given the point x equals minus 2. So in order to Taylor expand, we need to divide this by a certain value, and we get that value by moving everything to one side, so this equation equals 0. And to do that, you add 2 to both sides, which becomes x plus 2 equals 0. So, once you find that, you know that you must divide the original equation by x plus 2. So for part A, you set it up by doing 10x cubed minus 9x squared minus x minus 9. And you divide by x plus 2. The first step you take is to see how many times x goes into 10x cubed, which is 10x squared times. And then you multiply 10x squared to x plus 2 and subtract that value from the original equation. So you get 10x cubed plus 20x squared. After distributing the negative, you get 0, which you ignore, and for this value, you get minus 29x squared. And after you get that, you just bring down the rest of the values and solve again, just like you just did. That equals minus x minus 9. And now you figure how many times x goes into minus 29 squared, which is minus 29x times. So you multiply minus 29 to x plus 2 and subtract that value from this value, in which you get minus 29x squared minus 48x. Oh, my bad. 59x. Once you distribute the negative, you get this is equal to 0, so you ignore it, and you get that this is equal to 57x. Then you bring the 9 down, so you get 57x minus 9, and you can distribute, and you can simplify one step further by figuring out how many times x goes into 57x. And it's 57 times. So you do plus 57, multiply 57 by x plus 2, and subtract that value. So we get minus 57x plus 114, which this gives you 0 once you distribute the negative, so you ignore it, and this gives you minus 123. And that is as far as we can go for this step. So once you have that all divided out, after the first step of your expansion, you have, or you know, that x plus 2 times 10x squared minus 24x plus 57 minus 123. This is what you get. But looking at it, you can tell that this part can be expanded even further. So why don't we do that, to make it easier to simplify at the very end. So to do that, we will take 10x squared minus 29x plus 57 all divided by x plus 2 once again. So we figure out how many times x goes into 10x squared, which is 10x, and you multiply this by x plus 2 and subtract by that value. So you get 10x squared plus 20x, which this is 0 after you distribute the negative, so you ignore this value. And for this one, you get minus 49x. After that, you bring down whatever's remaining, which is plus 57, and you do the same step again. You figure out how many times x goes into minus 49 times, and then you subtract minus 40, and then you multiply minus 49 to x plus 2, and subtract that value from what we have left. So you'd subtract the value of minus 49x minus 98, which once you distribute the negative gives you 0, which you ignore, and 155. And that's as simple as you can make this. So we go back to writing out the expanded form. Originally, we had x plus 2 times 10x squared minus 29x plus 57 all minus 123. But after expanding this further, we found that a simple version of this is x plus 2 times x plus 2 times 10x minus 49 all plus 155 all minus 123. After you have this, you distribute x plus 2 inside the brackets, which gets you x plus 2 squared times 10x minus 49 plus 155x plus 2 minus 123. To simplify even further, this just transfers down, and this all becomes 155x plus 187, which means this is what the Taylor expanded form of the original equation looks like. Now we look at part B, which tells us to find the slope and equation of the tangent line at the same given point of the same polynomial. And that makes what we have to do very easy, because in order to find the equation of a tangent line to a polynomial equation at a certain point, all you do is Taylor expand all the way down to the end, which we have already done. And once you get to that point, you disregard the beginning part and keep the end. And that is your equation for the tangent line. So for part B, we know the slope and equation right away. The slope is 155, and the equation is y equals 155x plus 187.